As the demand for electric vehicles continues to rise, so does the need for more advanced and efficient battery technology. The current lithium-ion batteries have served us well, but it's time to look towards the next generation of batteries that can offer higher performance and energy density. In the race to develop these high-performing alternatives, companies like Toyota and CATL have been leading the way in the development of solid-state batteries. These batteries are seen as the future of electric vehicle power sources due to their potential to provide greater energy density and improved safety. However, amidst all the competition, a European project known as HELENA has been making waves with its groundbreaking solid-state battery technology. This project has been gaining attention for its innovative approach and potential to revolutionize the electric vehicle industry. So, what sets the HELENA project apart from the rest? Join us as we discuss how Europe's new solid-state battery technology just shocked the EV industry. Alright, let's dive into the world of these super-hyped batteries everyone's talking about. All solid-state lithium metal batteries, or ASLMBs for short. These things are like the rock stars of the battery world, generating a ton of buzz because they can hold way more energy than your average battery, and are much safer too. The secret sauce behind ASLMs is the solid-state electrolyte. Think of it as a new and improved battery separator, ditching the old flammable liquid stuff for a solid alternative. Researchers are especially excited about something they call solid-state halide electrolytes. These guys are like the ultimate conductors for the tiny charged particles that make batteries work, and they can handle super high voltages, basically the Michael Jordan of electrolytes. Now, let's shift gears and talk about a pressing issue: those nasty CO2 emissions coming from transportation. Did you know this sector is responsible for a whopping 30% of all CO2 emissions? Yeah, it's a big problem, with road and air travel being the main offenders. If we want to tackle climate change, we need a serious transportation makeover. That's where electric vehicles come in. These are poised to be the savior of the environment, using energy way more efficiently than those gas-guzzling dinosaurs of the past. But here's the thing, it's not just about how EVs use energy, it's about how they're made. That's where European-made batteries enter the picture. These batteries are designed with a low carbon footprint in mind, following a circular economy approach throughout their entire production process. This is where HELENA comes in. HELENA stands for Halide Solid-State Batteries for Electric Vehicles and Aircraft, and this project is really making interesting and groundbreaking progress in battery technology. They're basically building super-powered batteries designed to handle heavy use and keep going strong for a long time. Imagine an EV battery that can handle anything you throw at it, or an airplane battery that lets you fly farther and cleaner than ever before. Pretty futuristic, right? This project kicked off about a year and a half ago, led by CIC Energy Goon Research Center. Now, they're celebrating a major milestone, building the first solid-state battery cell with a special ingredient called a halide electrolyte. Here's why this is such a big deal. The halide electrolyte is a superconductor, allowing the battery to work at high power even in cold temperatures. Plus, it doesn't need any special storage conditions, making it perfect for real-world use in factories and on the road. For safety nerds out there, the halide electrolyte is also super stable at high temperatures, another win. The first-generation HELENA battery uses a lithium metal anode, the halide electrolyte we mentioned, and a special NMC 622 cathode that can hold a lot of charge. So far, things are looking great. The researchers are confident they're on track to meet their goals by the project deadline of May 2026. By that time, they aim to develop solid-state batteries with incredibly high energy density and performance. Basically, batteries that can go further and faster on a single charge. This is a huge leap forward for electric vehicles and airplanes, and it could pave the way for a much cleaner and more sustainable transportation system in Europe and beyond. But HELENA isn't a one-man show. This project is a collaboration between 15 different organizations, including some heavy hitters in the research and technology world. From the CIC Energy Goon Research Center, leading the charge, to big names like AIT, Austrian Institute of Technology, St. Riches, and Umor, there's a lot of brainpower behind this project. So what exactly makes HELENA so special? Well, they're tackling the need for safer, more efficient batteries that can pack a serious punch in terms of power. These aren't your average lithium-ion batteries. These are next-gen solid-state battery cells, also known as the 4B generation. They're made with a bunch of fancy materials like high-capacity nickel-rich cathodes, NMC for short, high-energy lithium metal anodes, and something called lithium-ion superionic halide solid electrolytes. Don't worry about remembering all these technical terms, but just know this: This tech has the potential to revolutionize electric vehicles and airplanes, making them cleaner and more efficient than ever before. This is a huge step towards a greener Europe, and that's something we can all get behind. Now let's get down to the nitty-gritty of what HELENA is actually doing. One of the key players, AIT, are the ones in the lab cooking up these battery components. They're basically the master chefs of the battery world, meticulously preparing each part and assembling the cells. They're also working on a mysterious substance called catholite. This project seems like something out of a sci-fi movie, running all sorts of tests to ensure everything works perfectly together. They aren't just building batteries in a vacuum. They're also simulating how these batteries would behave in real-world situations, both in cars and airplanes. Essentially, they're putting these batteries through their paces before they ever hit the road or sky. HELENA is all about making sure these next-gen batteries are safe, efficient, and ready to take electric vehicles and airplanes to the next level. One of the things HELENA is absolutely excelling at is figuring out how to handle and test these new batteries safely. But HELENA isn't just about safety, they're also champions of sustainability. The project has developed a stellar recycling plan for these batteries, so you can feel good about using them without adding to a landfill. It's a win-win for everyone. Clean power for our vehicles and a responsible approach to the environment. Now let's talk about the real reason everyone's excited about HELENA performance. Their goal is to give electric vehicles a major power-up. Imagine traveling longer distances and charging your car in a fraction of the time. That's the kind of future HELENA is working towards. They're making electric cars far more practical for everyone, not just early adopters. And the cherry on top? As they scale up this technology, the cost of these batteries is expected to go down too. Any manufacturer will tell you that making all solid-state batteries on a large scale is no walk in the park. There's a lot that needs to be taken into account when it comes to making those batteries on a big scale. First up are the active materials, the secret sauce that stores all that energy. Scaling those up for mass production is no easy feat. Thankfully, the HELA project isn't going it alone. Umicore is an expert in positive active materials, and the company is helping to ensure they have the best stuff around and enough of it to keep the production line humming. But active materials are just one piece of the puzzle. There's also the solid electrolyte. Especially when you're dealing with halides, these things are like fussy celebrities, they can't stand a drop of moisture. Luckily, Saint-Gobain has over a decade of experience handling these delicate materials, so they're on point when it comes to keeping things dry during production. Within the HELA project, Saint-Gobain takes charge of the development of halide battery technology by providing best-in-class halide electrolyte materials to the consortium, while optimizing and considerably improving the performance and manufacturability properties of the electrolytes and supporting the development of halide-based cell components. And let's not forget the coatings, they're like the invisible bodyguards of the battery, keeping everything stable and running smoothly. This is where the experts from Lion, Vito, and RWTH come in. These teams have devised some ingenious solutions for protecting the negative electrodes with super thin, uniform, and super strong layers. All this hard work is leading to a major breakthrough, the successful integration of lithium metal into the battery cell. That's a big deal because lithium metal is key to super efficient and long-lasting batteries. Another important aspect of this project is the inclusion of halides. Halides play a crucial role in various projects, especially in different materials. These compounds offer a range of benefits that make them highly desirable for use in a variety of applications. One of the key advantages of halides is their impressive ionic conductivity, which surpasses 1 millisiemens per centimeter. This high level of conductivity makes them extremely efficient for numerous scenarios where fast ion transport is essential. Additionally, halides boast a relatively low synthesis temperature, typically below 600 degrees Celsius. This lower temperature requirement not only simplifies the manufacturing process, but also reduces energy consumption, making halides a more sustainable option. Furthermore, the mechanical properties of halides make them highly conducive to shaping, offering flexibility in their application. This characteristic sets them apart from oxide electrolytes, which often necessitate high temperatures for production and shaping, and tend to have lower ionic conductivity. Another significant advantage of halides is their excellent oxidation stability, particularly in comparison to sulfides. With an oxidation stability exceeding 4.3 volts versus lithium, halides demonstrate remarkable resilience, making them suitable for use in demanding environments. Also, the safety aspect of halides cannot be overlooked. Despite their reactivity to humidity, These compounds do not produce toxic byproducts when they come into contact with water. This inherent safety feature enhances their appeal for various industrial and commercial applications. In the end, HELENA seems to be on the precipice of something big, and we can't wait for these batteries to hit the streets. What do you think about this? Let us know in the comments section.